helium. Well, my friend Chris, the scientist, he was wondering if we could get a balloon to float in the air forever. So he went out into the field and he's performed some experiments. We're going to watch a video of my friend Chris trying to get his balloon to float forever. Alright, there's Chris now. And there's his friend, the balloon. This is the day one. It was inflated just a few moments before this video was began shooting. As you see, Chris is having a great time with this balloon. It's on a swing, on a little pony ride. It's floating perfectly above his head. Even when he jumps off, the balloon will still float. Alright, Chris is doing some scientific stuff there. As you can tell, what a scientific looking faces he's about to make. Oh yeah, that's very scientifically there. That's day two. The balloon's still floating pretty good, I think so. Chris is happy with it. He's going to test it out a little bit more, take it on some more slides. Alright, it's still floating. Even on the bridge, that balloon is floating in the air just fine. Even down the slides. Oh, Chris almost fell, but the balloon's still floating. Alright, doing some more scientific tests there. Oh, look at the concentration on that face there. Alright, his calculations are in. It looks like that balloon's still floating, but not as high. Test day three. Oh no! Chris is sad that balloon isn't floating very much at all. Oh, so sad, Chris. Now what's happening with that balloon is that it's made up of very stretchy molecules that allows helium to escape and it actually lets air inside. So as the helium's escaping, it's becoming the same density as the air around it, so the balloon isn't going to float. So we can test that out with our CO2 chamber right here. We're going to test out buoyancy. Buoyancy is the ability of an object to rise in the air or float in the water. So I need a volunteer for this one. You raise your hand, come on up. What we have here is we have our CO2 chamber. It's just dry ice at the bottom of this chamber. Dry ice goes through a process called sublimation, where it goes straight from a solid to a gas. Alright. So as this dry ice begins to melt, it's going to become a gas. It's going to become CO2, carbon dioxide. What I need you to do, come on over here, what's your name? Dion, in just a moment you're going to take that off and you're going to start blowing bubbles into our dry ice CO2 chamber. Go ahead and get it ready, get it set. Alright, looks like we have a good layer of carbon dioxide in the bottom. Alright, go ahead and blow some bubbles in there. Alright, that's good, that's good. So you can see those bubbles are kind of flowing up there, right? They're resting on top of the layer of carbon dioxide. That's because the air out of your lungs is less dense than the carbon dioxide inside. That means the air is going to stay floating. But just like the balloon, those bubbles aren't perfectly airtight. So some of the carbon dioxide is getting inside those bubbles and they're slowly going to sink to the bottom.